Okay, so today we're going to study or discuss the remainder theorem. The remainder theorem is stated like this: when a polynomial p of x is divided by a factor, for example x minus a, the remainder of all of that action is p of a. It may not sound that interesting, but in reality the implications are quite astonishing. So what we can do is see what types of questions we'll be needing to prepare ourselves for. Alright, so there's basically two occurrences where you'll be using the remainder theorem quite a bit. Alright, the remainder theorem then leads way into more specialized and useful theorems. But these are the two instances. Use the remainder theorem. We'll just start abbreviating. To find the remainder when polynomial 6x to the third minus 8x squared plus 5 is divided by x minus 3. Okay, so the remainder theorem comes in handy in that after you've completed a polynomial division, you could use the remainder theorem to determine whether or not you have the correct answer. So use the remainder theorem to find the remainder when this polynomial px plus all of that, p of x, is divided by x minus 3. And so in the end, let's go ahead and use the remainder theorem. That means the remainder is actually just equal to p of a, and a in this case happens to be 3. So I can say real quickly and easily the remainder is p of 3. That's pretty easy because p of 3 is actually just going to be 6 times 3 to the third minus 8 times 3 squared plus 5. And so this is a big one here. 3 to the third is 27. 27 times 6 is what is that? 162. 3 squared is 9. 9 times 8 is 72, and plus 5. 162 minus 72 is 90. 90 plus 5 is 95. Okay, and so the remainder of this, if I were to go ahead and divide this polynomial by this binomial, I would get a remainder of 95. Okay, and so that would be one use of the remainder theorem. Another use of the remainder theorem. Example: This one will probably, both of these definitely are going to show up on a test of some sort. Let's say I've got a polynomial. And the question will be find a value of k so that when 5x to the fourth minus kx to the third plus 12, find a value of k so that this divided by, let's go with 2x minus 3 gives a remainder of 8. So find a value of k so that when you take this and divide it by this, so I'm actually looking for a particular value of k, I get a remainder of 8. Well, according to the remainder theorem, is that when a polynomial is divided by a particular factor, they have that situation. A polynomial divided by a particular factor. In this case, a binomial. In this case, a binomial as well, which I'm going to put a little caveat to the remainder theorem as well. And what happens if this factor is of the form ax minus b, which we have right here in this case, then the remainder is actually p of b over a. Okay, and so I take this situation here. Let me spread out so you can kind of see this a little bit better. Now I have an ax minus b here, and my remainder is going to be p of b over a. Now when I take this and divide it by this, which I'm doing, I should get a remainder. I want a remainder of 8, so I'm going to say that that remainder, 8, is actually going to be equal to p of b over a, or 3 over 2. Alright? And so this is basically the end here. It says when a polynomial p of x is divided by ax minus b, the remainder is, it always is, p of b over a. So look at what we want is we want to find a k value that gives a remainder of 8. So if the remainder always is p of b over a, I can set it equal to the remainder that we want. We want a remainder of 8. This is going to now be equal to 8. Very good. Now that's done. One last thing though is, what is p of 3/2? Well, p of 3/2 is simply you take the polynomial and you evaluate it at 3/2. So I write that down over here. I'll take this polynomial, 5 3/2 to the 4th, and I'll write this down, minus k times 3/2 plus 12, and this is actually equal to 8. Still equal to 8. And so, if you notice here, at this point, I have a equation where the only thing in there that's a variable is k. And so, what I can do is I can solve for k. So solving for k is going to take a little bit of algebra, which I'll do right here. Alright? And so this will end up being the answer. K is equal to some number. And remember, the first question is find a value of k. That's basically what we're looking for, so that when this is divided by this, I get a remainder of 8. Okay? What I'm going to now do is I'm going to take my 8, put it here, and set it equal to this, which the remainder theorem tells me should be the remainder, or is the remainder. And so now I'll do this algebra here. And the algebra would be 5 times 3 to the 4th. 3 times 3 is 9, times 3 is 27, times 1 is 81. 5 times 81 over 2 minus k. This was a third, by the way. I didn't carry it down. Times 27 over 8 plus 12 equals 8. You shouldn't really, hopefully you're not afraid of fractions too much, because we're going to be using fractions quite a bit in this class. But I'll get out the calculator and maybe help make some adjustments here. I'm just going to quickly do 5 times 81 here. 5 times 81 equals, 5 times 81. So 5 times 81 is equal to 405. So this would be 405 over 2 is minus k times 27 over 8 is equal to 8 minus 12, which happens to be a negative 4. Okay, so now I've got this minus that is equal to a negative 4. So notice I just took the 12 over and subtracted it. Now I'm going to take this over and subtract it. So I get a negative k times 27/8 is equal to a negative 4 minus this. The negative 4 I'm going to write as a negative 8/2, because I know I'm going to have to get a common denominator here. 405 times over 2. So notice again, I just took this and subtracted it over to this side, but I did get a common denominator for this negative 4, planning ahead a little bit there. So now 405 negative and an 8 negative, negative 8 minus 405 is going to be equal to a 405 minus 8. Oh, my calculator's all messed up here. It keeps putting the plus signs. Oh, I think it's broken. Anyway, 405 minus 8, I could just do that one. It's going to be 397 over 2. No, actually I'm adding them. 413. Okay, so now what I've got here is this is equal to 413. And so what I'll do is get rid of that for now. I'll say a negative k times 27/8 is equal to a negative 413 squared over 2. Sorry. Took this and wrote it up here. And so now, in order to solve for k in this situation, I'm going to multiply by 8/27, negative 8/27, and multiply by a negative 8/27. So the k value that I'm interested in is, notice how, since I've multiplied, this was a negative k 27, negative k times 27/8. This 8 effectively gets rid of that 8. That 27 gets rid of that 27. That negative gets rid of that negative. And that's why I chose to multiply by a negative 8/27 in order to get rid of everything. Notice how everything is gone except for the k. Now on this side, I have to multiply by a negative 8/27 as well, because I can't do one thing to one side of the equation without the other, or without doing the same to the other. And so now I figure out what this is here, okay? Yep. And so the idea here is that I get 413 times 8, 413, and so you just multiply it out, which I can let you guys do. 413 times 2, just to speed the things along, times a negative 27/8, or 8/27, which, remember that when you multiply fractions, you multiply the numerators and the denominators. These will cancel out, so k is actually equal to 413 times 8 divided by 2 times 27. And you just multiply that out right there. And that's the result, okay? So that would be a couple of things on the remainder theorem.